Welcome to aminacademy.com. In physics, let us discuss about reflection in spherical mirrors. In that, we will discuss detailedly about ray diagrams, how to draw a ray diagram. Ray diagrams are used to depict the image formation by tracing the path of light rays, that is incident ray and reflected rays. By using geometry, they are drawn in order for anyone to view a point on the image of an object. This ray diagram depend on the position of the object. General rule. Imagine these rules. It's important how to draw a ray diagram by using general rules. Any ray of that light passes through the mirror is always parallel to the principal axis. You have to remember a ray is passes through the mirror, it is parallel to principal axis. That means look at here this is a principal axis, rays are like. Any ray of light that passes through the mirror always passes through the principal focus of the mirror after reflection. That means any ray light passes through the mirror always reflect back through the focus. Means look at here, this is a focus. One ray go like, it come back like. All rays parallel to principal axis and reflect back through a focus. Any ray of light passes through the center of the curvature of any mirror is reflected back along the same path. Means suppose a mirror if passes through this and come back same position, same point, return back. Next, any incident ray which is not parallel to the principal axis is always reflected diagonally, and incident ray and the reflected ray always follow the laws of reflection. The angles formed by these rays are equal to each other. Now we'll discuss the ray diagrams for concave mirror for different position of the object. For a concave mirror, there are 6 possible positions where the objects can be positioned and an image is formed. Look at here. First, an object is positioned at infinity. That means the ray PR and QS coming from infinity and falls on a mirror surface and reflect back through the focus. So this ray and this ray focus through the focus, all rays. When object is placed at infinity, the rays PQ and RS parallel to the axis and reflected from the point Q, and that means these 2 rays passes through the point focus. Next one, object is positioned between the infinity and center of curvature. Suppose object is in between infinity and here the curvature point C. Here this is object, NM is object. First ray by rule parallel to through M parallel to the main axis, principal axis, and come back to the focus. And one more ray passes through the center curvature center and come back that position. So in between is formed that image. Here, look at here, Mn is the object. This is an image. You can put it in this here. Here, the object Mn is placed between infinity and center of the curvature C of a concave mirror. Then the ray MP parallel to the principal axis. Another ray MQ that passes through the center of the curvature and both intersect and forms an image here. Next is object is positioned at center of curvature. That means object is at the center of curvature, that is object is Mn, and one ray passes parallel to the principal axis and come back through F, and another ray that is from M passes through, look at here, and one ray Mn is parallel to and come back to the focus, and another ray through the focus. And here this object is exactly equal size and inverted here, Mn. When an object Mn is placed that at the center of the curvature F, AC, then a ray MP parallel to the principal axis and another ray MQ that passes through the principal focus F after reflection intersect each other at point M dash. Point M dash right below there where the object Mn is positioned. Hence, the properties of the images formed in this case are that images is formed at the center of the curvature. The image is same size. Image is the same size and the object of the image and real and inverted. It's a real and inverted up down. Next is object is positioned between the center of the curvature C and the principal axis. That means object is, the position is between center of the curvature C and point F, focus. That is here object. That one ray passes through M parallel to principal axis and come back through F. And through F and here, so we can form the image here N dash M dash. Look at here. The object Mn is placed between the center of curvature C and the principal focus F. Then the ray MP parallel to the principal axis and another ray MQ passing through the principal focus F intersect each other beyond the center of the curvature C at the point M dash. Hence, the properties of the images formed here are that the image is formed beyond the center of the curvature C and the image is real and inverted. Here image is beyond the center of the curvature and is the same size and inverted. Next is object is positioned at principal focus. Object is at the principal focus. What happened? That ray from M passes through parallel to the principal axis and come back to focus point. Another ray passes through center of curvature and return back, so it is parallel. Two things are here parallel. RQ and SP is the rays are parallel. Object Mn is positioned at the principal focus F, then ray MP parallel to the principal axis passes through the principal focus F, giving reflected RS. PS, second ray MQ that passes through the center of curvature is reflected along the same path, giving the reflected ray QR. Here, since rays PS and QR becomes parallel to each other, and therefore the image formation is at infinity. Image formation is at infinity, but here the image is not nearer to the mirror, it's at infinity. Here the properties of the image formed are highly enlarged images and real and inverted images. Objects is next one. Object is positioned between principal focus F and the pore. That look at your object is between the focus and the center of the mirror. So here this Mn and one ray passes through M to the mirror face and come back through F, and another ray passes through C and come back like that. So the image is formed in front of this here, this the both rays this SQ and RP meet at the point M days. So M days, N days is there, our image. Object Mn is positioned between the principal focus F and pole P. Then the ray MP parallel to the principal axis passes through the principal focus F, giving the reflected rays PS and second ray MQ that passes through the center of the curvature is reflected along the same path, giving the reflected ray QR. Now, since the reflected rays PS and QR are diverging away, hence cannot intersect each other. Hence, its reflected rays PS and QR are extended behind that mirror by dotted line, because it is imaginary. Dotted line. In doing so, the rays PS and QR appears to intersect each other at point M days backward. Therefore, the properties of the image formed are formed behind the mirror. Images are highly enlarged. Images are virtual and erect. Virtual and erect means here Mn is a object, M dash N dash is a image. It is enlarged and erect and enlarged and erect, highly enlarged and erect. Virtual, it's not a real image. Now, what we talked about the ray diagram in different positions, about 6 positions, we come to in table form. This is more useful to remember. Position object at infinity, position of the image at the focus, nature and size of the image real with inverted diminished. Used as a collector of radiation in solar heating devices. This is used solar cooker, solar heaters like. Next one, beyond the center of the curvature. It's not applicable. And at the center of curvature, what we talked, at the center of curvature itself, image also center of curvature, real inverted of the same size as the object. So this table is more useful. If you understand the ray diagram, we can fill the table yourself. But very important is how to draw a ray diagram. Please go back this video to get idea how to draw the ray diagram in different positions. Next one, the ray diagram for a convex mirror. Just one or two positions here. In the case of convex mirror, there are only two possible positions where the object can be positioned and an image can be formed. Object is positioned at infinity. Suppose this is actually it is a mirror given in that it's a convex mirror. Then suppose rays are coming, actually rays are coming from infinity and it falls on the mirror. When the object is at infinity, the ray Mn and Px that are parallel to the principal axis F, principal axis this F, are divergent in the direction NZ. It go out like here. Actually, the diverged rays NZ and XY are extended behind the mirror where they intersect each other at the principal focus F. Hence, in this case, properties of the images formed are formed at the principal focus F behind the mirror and are highly diminished, and images are virtual and erect. Next one, object is positioned between the pole and the principal focus. Here, the object is here. Object is here, so it's ray go and it goes through the center and like this dotted line and show this one. When the object Mn is placed between pole P and infinity, the ray MC that starts from point M of the object Mn that's running parallel to the principal axis is reflected along CY. Therefore, this is image is formed here. Now, this is the tabular form. The size and nature of the images formed by convex mirror are given in the table. Position is at infinity. That object position is at infinity. That position of the image is at F, highly diminished, the point like, and point sized images there. Nature of the image, virtual and erect. Next one, between the infinity and pole, that is position of the image also between P and F. Image size diminished, and virtual and erect. So far we discussed little lengthy about how to draw a ray diagram and what the size and nature of the image in different position for concave and convex mirror, and tabular form of the positions of the object and the image, and users also. We have done. Please subscribe our YouTube channel.